Hello everyone, welcome to Spring Security 702 Master. My name is Rishabh and I'm going to start a complete end-to-end playlist over Spring Security 7 with Java 25. In this course, we are going to learn Spring Security 7 with Java 25. We are mastering it with fundamentals to enterprise grade implementation. Let me just walk you through what we are going to cover in this journey. And before starting our video, I would just like you to subscribe to this channel for the complete playlist and all the upcoming videos. Let me just start with our first slide. Okay, so we will start with what Spring Security actually is. What is the enterprise standard for securing your Spring application, and what's new in Spring Security 7, and how it fits into modern architecture like microservice and cloud native systems. By the end of this end of the couple of sessions, you will clearly understand the security flows, some of these core security components, some of the core security features provided by Spring, the complete Spring security architecture, and the actual core architecture, which is basically very much helpful in securing your enterprise application. So let me just start with our today's agenda. So we will be covering some of the important classes, interfaces, and annotations of your Spring security, like SecurityFilterChain, Authentication Manager, User Detail Service, and there are a number of classes, interfaces, and annotation. But there are a limited number of interfaces, classes, and annotation that is actually be utilized in your enterprise application or a production grade application. So we do not need to focus on other filters, other annotation. Just we need to focus on what we are learning in this video, and this would be more than sufficient if you are going through this video and learning it end to end. So next is our method level security. So we will be implementing method level security with couple of annotations: pre-authorized, post-authorized, secured, custom expression. So you will learn how to secure services at the business logic level, and not just at the controller level. So this is critical in your enterprise application to learn. Next is the password security and the strategies. So there are different types of password strategies. What basically used in production grade application, what we need to use, what we need to avoid, what is available for the development purpose. So we will completely understand the theory and its implementation in this particular section. The next one is configuring the authentication and authorization. We will be like building real configuration for form login, basic authentication, custom logic on login logics, and stateless authentication. We will be configuring everything manually, so you fully understand what is happening into the securing the application. Next is your securing web applications. So we will secure REST APIs, MVC application, microservices, and stateless systems. So you learn how to use session-based security and when to go for stateless. Then RBAC for implementing roles, authorities, and fine-grained access controls. Next is CORS, CSRF. So we will clearly understand what CORS is, how browser blocks CORS, CSRF attacks, when not to disable it, when we need to enable it, when to use it. So this is basically a very important topic among the many developers. And next we will be going with JWT implementation for stateless authentication, access token, refresh token, token validation filter, custom claims, expiration handling, and you will implement it step by step and without hiding any complexity. It is a very easy topic and easy to implement. Next is OAuth2 and OpenID Connect. So we will be integrating the OAuth2 login, and we will be basically learning some of the couple of important authentication flows and like client credentials, Pixie, authorization, OpenID. So these are the different OpenID Connect flows. So we will understand it. And next is social logins. So like Google login, GitHub login, or any other OAuth providers integration logging. So we will also handle external identity providers here. Then we have the MFA. MFA is basically introduced in Spring Security 7. So it introduced couple of multi-factor authentication method like OTT, email-based verification, biometric-based verification. So we will also do hands-on over those particular things for Spring Security 7. Then we will be moving with Keycloak Spring Authorization Server. So we will be utilizing an open source Keycloak for as an authorization server, and we can also build our own Spring authorization server, and we will be integrating into our securing or integrating into our web application. Then we have the everything securing an enterprise application. So we will be having a banking app or something similar to that, so that we will be doing a production grade architecture, creating a production grade architecture and securing all the microservices, gateway level security, token propagation, and best practices and real world patterns that we need to follow. This is where like move from developer to security architect mindset. So next I'll just we'll start the fundamentals and understanding how Spring Security actually works internally, and we'll begin this journey with our playlist. So next is let me just quickly move to our next slide, which is some of the key security principles. So now before we jump into writing the configuration, like we need to understand something very important, like security is more not just about the configuration, it is about the principle. So if your principles are wrong, your configuration will also be wrong. And let's go through the key security principle that every backend engineer must understand. So the first one is least privilege. So this is one of the most fundamental security principle. Least privilege means a user or a system should only have the minimum permissions required to perform their task, nothing more. So like if I take an example, a normal user should not have admin privileges, or read-only API should not have the right access to the database. And in Spring Security, we implemented this using the roles, authority, method level security, fine-grained access rules. Next is the attack surface minimization. So this basically means that all of your possible entry points where an attacker can interact with your system. So this basically includes like open endpoint, unused APIs, publicly exposed services, debug endpoints, actuators, missing configuration, cores. So in Spring Security 7, you should explicitly define what is allowed instead of allowing everything and blocking it later. So whitelisting, blacklisting strategy that we will also look. Then important principle is centralized security services. So basically in enterprise system, security should not be duplicated across services. Instead, each microservice manage its own authentication logic. So basically, no microservice should implement its own authentication logic. The authentication authorization logic should be a central part, and we should use centralized IDPs, use OAuth2 authorization server, Keycloak, Spring authorization server. So this basically benefits us in consistent policies, rotation of your secrets, centralized token management, and better audit logging. So this is extremely important for in microservice architecture. And next is preparing for the error handling. So security failures will happen: invalid tokens, expired sessions, unauthorized access attempt, CSRF violation. So our system must handle them properly. So some of the bad practices that I usually see in the security related aspects is exposing the stack traces, returning sensitive error messages, leaking internal information. So there must be some good practices that we always need to follow. One of is like properly returning the actual status code and standardize some of the error response, implementing custom authentication, access denied, or some of the handlers. So basically here security is just not about blocking the request, it is about responding correctly to the user. Let me just move to our next slide. This is like what is the need of the security? So in every web application today, we have we have n number of APIs. We are storing user data, sensitive data, handles authentication, process transactions, integrates with the third party systems. So if you don't secure it, someone else will test it for you in production, and that is a very bad practice. So security protects us from securing our business logic, sensitive data, user identity, financial transaction, and in simple terms, security ensures only the right person can do the right action at the right time. So this is a main thing which is needed for what is the need of the security. Next is security is a non-functional requirement. So security is not a feature, it is a non-functional requirement. That means it does not directly add business functionality, but without it, your functionality becomes dangerous. So just like performance, scalability, reliability, security is also an NFR, and security must be treated as a core architectural concern, and you cannot add a security later. So security should be from the day zero, which is our next point. So this is extremely important if you are designing a system first and think about security later. So you will refactor everything, and there would be a big chaos if you are implementing it later. So you will introduce vulnerabilities, increase technical debt, and all of this would be very dangerous for a real enterprise system. So security starts at requirement gathering phase, initially from the requirement gathering phase, and it grows till your application is also growing. So next is like why security is important. So let's be practical. What happens if a security fails? A data breach, or identity theft, financial loss, legal penalties, compliance violation like GDPR, PCI, DSS. For companies, security incident can cost millions. So for developer, it can cost credibility. So that's why the security is very much important for any of the web application. Next is type of the security like authentication, authorization, data security, transport layer. So we will see this later on. And some of the most common attacks in the well-known market is SQL injection, XSS, CSRF, JWT tampering, session fixation. So we will deal with all this common attacks, and we will learn how to secure our application from this common attacks. Next is like, let me just move to our next slide. So, okay. So this is the, all right, now, like, let's understand like Spring Security using a simple but powerful analogy. So think of your application as a vault, not just a website, not just an API, a vault. So inside this vault, you have your business logic, sensitive data, financial information, token, secret, everything is there. And if you think like this, security design becomes very much clearer. So let's basically break it down. So before entering a vault, a guard stop you and ask like, who are you? So that is authentication in Spring Security terms, username or password. That is very much needed for your authentication, or JWT validation, OAuth login. So the authentication answers, are you really who you claim to be? So if authentication fails, you don't even enter into your vault or a system. The next is like the access list authorization. Now suppose you are authenticated, the guard inside the vault checks the access list. Can you touch this? Can you open this room? Are you allowed to get into this room? Or that is authorization. So in Spring Security, you can control it by roles, authorities. We will see in the actual implementation when we move to that particular part. And next is your filters. So filter is nothing but your CCTVs inside the vault. So even after entering the vault, monitors everything. So CCTV watches who entered, what they accessed, what is any suspicious activity or behavior is there. So in Spring Security, this is the filter chains. So filters are intercept every request, validates token, checks sessions, apply CSRF, and all of the things that you think whenever a request gets into the system. And before running the business logic or before reaching to the controller, there must be some predefined authentication or predefined work that needs to be done. So those would be the part of the filter chains. So every request is passed through it, and whatever you have written in on those filter chains, that would be executed for each request. Now encryption and hashing, this is basically the safe. So inside the vault, the data itself is protected. So even if someone breaks this, they still can't read that particular data. So there are different techniques: password hashing, signature verification, TLS, encryption at rest, and there are all different techniques also there for securing your data. The next is the threats. So why do we need all this? So because threats are real: CSRF, cause, session fixation. So Spring Security exists to protect your vault from this threats. So from the next section onwards, we will stop talking about the theory and we will do a little bit of theory and a little more over the practical part, and we will start implementing a couple of things. Before that, we will also do a small theory to understand how Spring Security internally works. And if you understood everything up to this point, you are ready to master the Spring Security, not just use it. So in the next module, we will dive straight into the implementation and start securing a real application. And let's move forward and start building the system the right way. So thanks for listening me, and just do subscribe to the channel so you don't miss the upcoming deep dive implementation modules. So see you in the next video. Thank you so much.